All right, hello again, ladies and gentlemen. I sure miss talking to you and having feedback and laughing with you. It's very boring teaching to myself. Okay, so this time I'm talking about Pre-Cal Skills E1, E2, and F2. Really quick, some of these are quite easy, so that's kind of nice. The first skill we're talking about is rational functions. This is the simple form of a rational function where we have some sort of simple number on top, like a 2 or 3. It could be half 2. It doesn't matter what it is. And in my denominator, we have x minus something and some value added on the outside. And we've done this before. Denominator domain, denominator domain. We always get excluded values from the domain. So in this case, x cannot equal whatever h happens to be. So when it asks you for excluded values, it always comes from the denominator. The denominator also gives us the equation of our vertical asymptote. And whatever's on the outside here, y equals k, is the equation of our horizontal asymptote. So make sure today on IXL, when you're entering equations, if it's an equation, you have to put x equals a number if it's the vertical asymptote, y equals a number if it's the horizontal asymptote. Don't leave that off, otherwise it's wrong. For excluded values, it's just asking what is the excluded value. So I think you could just enter in like -3 or -1, and that works just fine. We are going to solve rational equations. Cross multiply, factor, and solve. Okay. And then lastly, and I'm not going to do any examples of these except right here, we're converting from log form to exponential form and vice versa. And so here you can see we have a log equation and we want to convert that into exponential form. And so if you remember, how do you drop a log? You give it a swirly. And I wanted to just refresh your brains on that stuff. So we're going to start with the base, circle around, and pick up our power. And that's always going to equal the argument. Whoops, I reversed that. It's my dyslexia coming through there. Okay, so 3 to the 4th equals 81. And of course, you can check on your calculator, and I am doing that right now. 3 to the 4th does in fact equal 81. So yay for me. Okay, so here we are in exponential form. And you can see you're just filling in boxes on IXL. Here we have natural log, and I wanted you to remember that natural log is the same as log base e. So another way, instead of writing natural log, we could write log base e of 7 is approximately 1.9459. And if we want to convert to exponential form, then we would say that e to the power 1.9459 is approximately equal to 7. And however you write that, if it shows up in IXL, e to the 1.9459 is approximately equal to 7. So it might be reversed. Just write it down and rearrange if necessary. And they'll also have, the E might already be there, and you just have to enter in the power, maybe enter the 7, that sort of thing. So it's a little fill in the blanks. So natural log is the same as log base E. Log with no base here, if you remember, that is the common log. And our number system is base 10. So whenever you see, I'm not going to rewrite that. I'm just going to smush in the base 10 there. So if you don't see a base, it's base 10. And again, we can rearrange 10 to the -1 power equals 0.1. And again, all these things you can check on your calculator. So 10 to the -1 equals 0.1. Works perfectly. So play around with those. It's just converting back and forth from one form to the other. So hopefully that'll work. easily. So here we are first with rational fractional functions. Example 1, answer the following. Remember, you can pause this video, rewind whenever you need to, and you don't even need to watch it if you think you remember all of this stuff. So the first one here, I have a nice little picture of a rational function. I don't know if you can see these markings too well. There we go. I should have changed the step in Desmos when I did this. There we go. That's better. All right. Answer the following. What is the equation of the horizontal asymptote? So first of all, it's an equation. And that's really important to me. That means that you got to have an equation. And if you have an equation, you have to have something equals something. That is an equation. So make sure if it's asking for an equation, you give an equation. We want the horizontal asymptote. And so if we're looking, our horizontal asymptote is a horizontal line, and you can see our rational function seems to be getting close to what would be an asymptote here. We're approaching this sort of horizontal line. You can make guesses. It's pretty clear. I did the IXL skill for this, so I know it'll be pretty easy for you. We're approaching 2 on the y-axis. So that is y equals 2 for the equation of the horizontal asymptote. I'm just going to write that down there so you remember, because I also want to ask you about the vertical asymptote, just for giggles here. On this one, the vertical asymptote that we are approaching is a vertical line, and you can see we're approaching something here and getting closer and closer to something here. So you can pretty much see pretty clearly we have this vertical asymptote that is passing through 4 on the x-axis. So the equation of the vertical asymptote would be x equals 4. All right. So being able to identify those asymptotes is a really good skill, especially those of you going on to calculus. We can look at graphs and make assumptions, and most of the time they're going to be pretty good. What is the equation of the vertical asymptote? So again, it's asking for the equation of the vertical asymptote in this case. And this is our formula that they're giving us, our function rule. And it is the vertical asymptotes always come from the denominator. Domain, denominator, denominator, domain, and the vertical asymptotes come from that. So our vertical asymptote equation comes from solving. It's not x plus 2, it's an equation. If you were to take x plus 2 and set it equal to 0 and subtract 2, then that is our equation, x equals -2. So isolating x is going to give you your vertical asymptote. I also want to just go ahead and ask, what's the equation of the horizontal asymptote if you're given a function like this? The horizontal asymptote is always this number on the outside. Y equals whatever is out here. So y equals 5 would be that horizontal asymptote. If you didn't see anything there, it'd be y equals 0. Nothing is there. If it was just an x, it'd be x equals 0. Nothing is there. Okay. And last, again, what is the excluded value? If you're given this function rule, well, the excluded value always comes from the denominator. So -2 is the excluded value. And that's all you would need to put in the box. At least that's all I had to put in on the questions that I did. So that is the number that if you plugged it in, it's going to be undefined. -2 plus 2 is a 0. 3 divided by anything, or 3 divided by 0, when the 0 is under, it's undefined. And that's what excluded value means. When is it undefined? So that's all you would need there. Pretty easy stuff. Not pretty easy, really easy, like ridiculous easy. Okay. Example 2, and only last one here. Solve the rational equation and check. I do believe it's going to say there may be 1 or 2 solutions, but it's going to give you 2 boxes all the time. So it could be that you only have 1 or two possible answers, please make sure they work. So plug them back in to check. We have a fraction equal to a fraction. So we're going to go ahead and cross multiply. So I have 1 times 5 is 5, and d times the denominator on the other side. I'm going to go ahead and distribute. D squared minus 4d. And since this is quadratic, I'm going to set it equal to 0, factor, and solve. So I'm going to subtract 5. D squared minus 4d minus 5. And then we can double bubble to find some possible solutions. D times d is d squared. What times what is negative 5? Negative 5 and positive 1. I heard you. I know you were answering out loud. I did hear it. It's miraculous. Okay. And again, you can check the rainbow just to make sure that we get our middle term, and we definitely do here. We can set each bubble equal to 0, and we get d equals 5 and d equals negative 1 as possible solutions. So I'm going to go ahead and plug those in to check. So I'm going to go ahead and plug in my 5. I'm just going to plug into my original. You could use the calculator if you wanted to. So 5 over 5. So let's see, so easy to do by hand, especially on something like this. 5 minus 4 is 1. So we get 1 divided by 1 is 1, and 5 over 5 is 1. The left and the right balance perfectly. Plugging in negative 1, let's see if the same thing happens. We'd have 1 over negative 1 minus 4 is supposed to equal negative 1 over 5. And if I clean up the denominator here, I would get 1 over negative 5 is definitely equal to negative 1 over 5. Doesn't matter where that negative is. So both of these answers happen to check, and both of them happen to work. 4, if we had gotten a solution of d is equal to 4, 4 would be one that wouldn't work, because we know right off the bat here, d is not allowed to be 4, because it would be undefined when we plug in a 4. Can't have a 0 in the denominator. All right, let's look at letter B. I'm going to go ahead and cross multiply, which means I have c plus 10 times the entire 7c plus 2 is supposed to equal c plus 8 times the entire denominator 7c plus 10. This one's kind of ugly looking. We do need to FOIL, distribute these together. So I'm going to go ahead and do that. I'm going to do it in my head. So 7c squared. The outside is 2c and 70c. So that's going to be 72c. And then last times last is 20. Over here, I'm going to have 7c squared, the outside and the inside. 10c and 18 and 56. So 56 and 10 is 66 c's. Hopefully that's right. All right. Well, you'll happen to notice if we try and collect like terms here, subtract 7c squared, they're going to cancel out. So that's nice. And so I'm left with 72c plus 20 equals 66c plus 80. And I can go ahead and get my c's together. I'm going to subtract 66c. 72 minus 66 is 6 c's plus 20 equals 80. I'm going to go ahead and subtract the 20. So 6c, 80 minus 20 is 60, and it looks like c equals 10. And I'm going to go ahead for this one and check in my calculator. So I'm just going to go ahead and drop in our c value of 10, just to make sure the left side is balanced with the right side. So in my numerator, so I'm putting in parentheses, 10 plus 10 is 20. I could have done that in my head. Over 7 times 10 plus 10 in my denominator. And you'll notice I put parentheses just around that whole denominator. So I get 0.25, and we want to know, is it equal to what I plug in over here? Again, dropping in. So my numerator is 18. 10 plus 8 is 18, divided by 7 times 10 plus the 2. And again, I put parentheses around that whole denominator. And I get 0.25. So we know the left and the right balance perfectly. And so that is a great, great answer. If you had gotten an answer like, let's see, -2 and divide by 7, -2/7, that would be a false solution. So that one's not going to work because we're undefined at -2/7. Here as well, -10/7 is also undefined. So if you happen to get an answer like that, -2/7 or -10/7, then you know right away that answer can't possibly work. So it's always a good idea. So from this denominator, C is not allowed to equal -10/7. Always a good idea to recognize what is undefined right off the bat, answers that won't possibly work for us. All right, that should be good enough, ladies and gentlemen. You should now be able to do skills E2, E1, and F2. Thanks.